So today we're going to talk about why PDF, even if we love it, or we say we love it, is a difficult format to work with, especially in the context of document understanding. We will, of course, explain what we mean by document understanding, and we will go over a few technologies that are useful for this purpose. We will finish with examples where a good document understanding system helps with common PDF challenges. So today will be actually two presenters, so you don't think I'm the only one in the company. So my colleague Mathus is a senior developer and PDF specialist at Orpalis, and me, so you know me already, so former CEO of Orpalis, now doing marketing at PS PDF Kit, and I'm also on the board of the PDF Association. So now I will leave the PDF specialist talk about his favorite subject, and I will come back after.
So hi everybody. My name is Mathus Pizur, and I am a PDF developer at Orpalis, which is now part of the PS PDF Kit team. And today I would like to talk about one of the aspects of why many people come into this kind of conclusion when it comes to work with PDF and the PDF workflows in general. So why do we need to understand the PDF? Are they not understood already? Or why can't we just rip out the data from the PDF and basically push them forward into the process as a structured information? And in order to get to the bottom of this, basically we need to take a step back and look at the original premise of the PDF, which is a file format for digital distribution of final form documents. And effectively acting as a form of digital paper. So we need to understand that the PDF format was built with strong focus on the consistency, meaning the files should provide the same visual output on different machines, platforms, in present and also at any point in the future. There was a strong focus on fidelity with the imaging model inspired by the battle-tested PostScript imaging model, wide support for color spaces, fonts, blending, transparency, etc. Also, the focus was on convenience, providing the way to distribute documents with smaller memory footprints, ease of navigation, utilizing outlines, links, and some useful features like optional content groups and etc. again. And nevertheless, the focus on security. So with a wide variety of techniques to encrypt sensitive data, provide password-protected access and restrictions to the documents, and digital signatures and certifications of the documents. So this nature of the PDF led to something very functional for its purpose, but as the automation and digitization of the industry kicked in, the need to further process the PDF documents basically emerged, and at this stage, the PDF started to be a little bit problematic. So, because the way that PDF does not lie any restrictions on how the data should be put in, which should be actually, it mostly is about a visual representation at the start, and basically so for the start, I would like to start to have a look at digital reborn PDF documents first. These are our standard PDF documents many of you are using daily, most of the time created from some kind of underlying data, be it different document formats when it comes to the conversion of some raw data outputs processed by and compiled by various specialized generators, or just maybe some exports of daily office work. These PDF documents contain text and image graphic objects without any inherent structure at the content stream level, of course, and they make use of any available feature of the PDF if necessary, of course. So in order to illustrate this a little bit, let's have a look at the very basic example of content stream relation to the actual visual output. So in this basic example, the text object you can clearly see the relation between the text object of the PDF content stream and its visual representation that you will actually get when you will render the PDF. Now, you can notice that there is already a little bit too much fluff around the simple show text operator, which is basically setting the text transformation matrix, setting the font, and stuff like that. And basically, we need to do all of this in this case just to create one simple word on the page. Of course, this is not always the case. We can put the whole line into the show operator, or we can change the operators inside the show text operator. But since, again, as I said, there are no basically restrictions in the PDF how to do that, then we need to expect the worst. And when we are talking about expecting the worst, then let's take a look at second example, which is very similar to some. But this text object uses different show text operator, which basically enables you to provide character spacing in between singular characters or set of characters. And this is a very useful feature in many, many ways and widely used. But at the same time, it can be very much abused by many not so optimized PDF generators. And as you can see, the relation between the content stream and the actual visual output is already starting to get very, very blurry. And it's a lot harder to actually process the data and get the information out of the PDF. This trend, of course, does not stop just at the text object level. It is many times the usual story throughout the documents, and it's quite noticeable on the object level as well. Basically, where on the page content stream, where as you can see, the sequence of graphic objects, whether it is text or images, do not need to correspond to the actual order of how they appear on the output. I would just like to point out that I made a mistake there when I was copying and pasting stuff. So if anybody will notice that the content stream is actually not representing the visual part, I know about it. And I just noticed it too late. And yeah, this basically scales very, very well in the PDF. And this is a huge part of the problem, basically. The PDF page content stream by nature does not contain any advanced constructs like paragraphs, tables, heading definition, etc. Just like when painter is painting on canvas created by singular strokes, then basically you just replace those painter strokes by very simple graphic objects in the PDF, and you are creating the whole information. So this problem was basically identified quite early with regards to PDF. And it was partially addressed in the PDF 1.4 specification with the introduction of tag PDF. I'm sure everybody knows this, but let's repeat it once more. Tags are used basically to mark the graphic objects. So, for example, those that I was showing you. In the content stream, and then they are able to reference them in the so-called logical structure or structure tree that is kept outside of the content stream itself and makes possible to create sophisticated relation between the graphical objects, group them into the tables, headings, paragraph, and stuff like that. So, and this idea was very successfully and actively being perfected by the PDF UA specification to make the documents accessible, and in general, the feature is starting to gain more and more popularity in the industry. What I would like to point out that this was really just scratching the surface. If we would start to go into adding transparency to the problem, adding optional content groups, adding blending and images of various sorts, then the problem will be even deeper. So yeah, we are just scratching the surface on this, and that would probably be about it regarding digitally born PDF. And with that, we also need to basically point on the obvious elephant in the room, as we call it, which are the digitized PDFs. So basically, so as the name strongly suggests, the documents are a product of digitalization of existing paper documents. And as a result, the only information that we have in the PDF content stream is a raster representation of the image. So you can see that that's actually the graphic objects in the PDF content stream, which is just 2 lines. And basically we have no structure, we have no information about the data inside the raster. We are not able to tag anything, so that's also out of the game at this point. Yeah, all of this causes various problems. The documents are basically not searchable. They are not discoverable. They are problematic in day-to-day work. For example, if we are not able to extract simple text from the document, absolutely unusable in many automated workflows that need to handle the data locked inside the PDF documents, and obviously they are not accessible at all. So that would be the problem definition that we need. And now I would leave you to Elodie, and she will get you through some solutions and consequent benefits on the workflows.
Okay, so now let's move on to document understanding. I'm really sorry about this slide. I think I still had COVID when I did it, but it was funny for me at the time. But I showed it to some other people, and they didn't get the joke. It's document understanding. So, what is document understanding? So, it is at the core of any intelligent document processing solution. So, intelligent document processing, or IDP. I will give you a lot of acronyms today, so I'm sorry about that. So it's a very trendy term at the moment because its goal is to extract data from unstructured and semi-structured documents using OCR and artificial intelligence technologies. So any document that does not have predefined data model or is not organized in a predefined manner as unstructured data, which represents, like we said, about 90% of all documents generated. And about document understanding, we can distinguish 2 levels. So to obtain a first or basic level of document understanding, you will need a good layout analysis system and recognition engine. If you want a more advanced level of document understanding, you will need to add the first level we saw, and then you add natural language processing, so NLP capabilities. So now let's see more in details the different technologies involved in this process. Excuse me. So first is document layout analysis, so DLA. So document layout analysis is the identification and categorization of regions on a document. So it implies a geometric analysis of tables, pictures, equations, and barcodes, and the logical layout analysis, so it's paragraphs, lines, words, character of the document. Then the second technology you will need, of course, is OCR. So what do you find in an OCR engine? So an OCR solution is actually a complex system combining several engines that intervene at different stages of the process. So a standard OCR process includes at least the following steps. So first we have a pre-processing cleanup phase. This is where the document is straightened, despeckled, cleaned up with filters, so the text and other elements are made really clear and sharp. Then we have the thresholding, which is the segmentation of the document. Then we have the layout analysis, and then only we have the recognition phase. This is usually where we integrate an external engine, and then we have a post-processing phase. So there are issues with traditional OCR. So what we mean by traditional standard OCR is, no, I think Yeah, I talk about that after. So a traditional engine, OCR engine is not enough, especially in every document and everything that is not typed text on a perfectly white background. So for documents, for instance, with colored backgrounds, glaring, skew, text in table and graphics, handwritten text, and same font in different sizes, underlined text, well, all these situations and more, the traditional OCR won't work well. It also means that solutions built on this system are also hard to scale because they will require a lot of verification. If we take the example of Tesseract, which is often used in the industry and is considered, when used by itself, a traditional OCR engine. So at first, OCR was developed to OCR scan books. So this is why it's excellent to detect 2 column pages of text. However, there are 3 main constraints with this engine, because it can aggressively aggregate words into lines. The results are poor with business documents and unstructured documents in general. And Tesseract is also, it's almost impossible to maintain if you want to maintain yourself. So even with a good pre-processing phase, it does little to improve OCR results with an engine that relies on Tesseract only. This is why you now often see OCR engines combined with AI technologies like machine learning and deep learning to mitigate the traditional OCR limitations. So the tech number 3 that we're going to see is textual content key-value association. So this technology helps with document understanding. It's also called KVP. So key-value pairs are 2 related data items, so a key and a value. So the key defines the data and is fixed, and the value is variable and describes the key. So I give you an example here. And the list of use cases for KVP extraction is practically endless, and most, if not all, industries can benefit from implementing it into their processes, because once the information is extracted, it's easy to repurpose it where needed. So our organizations that manage paper-based form scan to PDF, native PDFs filled with form fields, and these are the obvious candidates for KVP. So we usually find KVP extraction in the following industries: so banking, finance, insurances, healthcare, government and public agency, HR, financial services for our industry. So really, basically, you could use it pretty much anywhere. Then another technology that is useful for document understanding is NLP, so natural language processing. So it's an AI technology that enables machines to understand human speech in text or voice. The voice part is the ASR part, so automatic speech recognition. So it's to communicate, it understands the speech in text or voice form to communicate with humans in their own natural language. So it includes 4 major steps. So first a lexical analysis, then a syntactic analysis, a semantic analysis, and then an output transformation. So NLP is essential for extracting data from unstructured documents. In unstructured documents, so data extraction happens in 2 phases that you need to have. So first, you need to extract unstructured information or text with OCR or a combination of OCR and deep learning. And then you need to make sense of this unstructured information with deep learning and NLP. So the next technology is named entity recognition, also called NER or NER. So NER is a form of natural language processing. So it's a subfield of artificial intelligence. It's a subtask of information extraction that tries to locate and classify named entities in unstructured text into predefined categories, such as person name, ID number, address, organization, etc. So this technology is used for key value pair extraction, so again for unstructured and semi-structured documents. But you have to know that building an algorithm with named entity recognition is not sufficient to address all these challenges. So not to mention that it can be a bit of an overkill to use it with structured documents, as it will use a lot of resources and time for nothing. And this is basically true for all the technology we saw today. So they need to work together. And because using one tool alone or choosing one tool over another one will not cover the majority of cases. So it can work in very specific and well-defined contexts, but for a general approach, it is not reliable enough. Traditional OCR doesn't work well on business documents, and of course, especially scanned PDFs. And OCR powered by deep learning technologies only can be very slow and uses unnecessary resources in some cases. So you don't want to use them again on Excel spreadsheets, for instance, where everything is already structured there. So the best approach is to go hybrid with an adaptive engine. So this kind of approach includes heuristics, mathematics, and combines all the various artificial intelligence technologies, capabilities, while making the best use of resources available. So how can the technologies we just saw can help us with some of the common PDF challenges? So of course, the best would always be to create better PDF in the first place. But unfortunately, we don't live in an ideal world, and I don't know if it will ever happen. So we need to find other solutions. So the first obvious improvement is for OCR, because benefits of a performant document understanding system on OCR are quite obvious, and we already mentioned them. So it improves the OCR recognition step, especially with LSTM-based recognizer. So it's an artificial neural network. It's also used in Tesseract. It permits to move beyond simple OCR processes and towards document understanding, as we just saw before. Another field of application is tagging, because so with a performant document understanding system on tagging, you can have automatic tagging. Of course, you have to be careful there, because you cannot rely on automatic tagging in all cases, but it will help quite a lot on many cases. And of course, it provides a better accessibility support by making the conversion to PDF UA easier. Then on conversions, so the benefits of a performant document understanding system, well, basically it will help to improve the quality of conversion of a fixed into an editable layout. For example, if you want to convert PDF to Office formats. This type of conversion, as we saw this morning with the Foxit presentation, is very difficult to achieve, especially on PDFs where we cannot distinguish where one paragraph or block of text starts and when the other ends. Then another field of application is indexing and labeling. So, and as with all automation tools, the global benefits of automatic indexing and labeling are always less errors, so less human intervention, quicker workflows, better compliance, and in the end, time won is less money spent. It also helps a lot with redaction, because by better locating information on the document, it's easier to remove it. It's a simple concept to understand, but it's much harder to achieve. Redaction that relies on OCR only is not performant on unstructured documents. So automatic or better smart redaction that relies on a strong document understanding system that includes all the technologies that we listed, on the contrary, is especially performant, retrieving text located in tables, graphics, and all the places where sensitive and personal information can hide. And finally, it's also really useful for hypercompression. So it's like compression, but better. So hypercompression relies heavily on a good document understanding system. It helps to identify areas, zone, layers, elements, and fonts, and it helps with mixed raster content compression, especially color detection compression, and PDF optimization, and makes them much more performant.